So in this video, we'll talk about an interesting topic about representing a given function as a power series. And if you look at such a problem, it's actually quite interesting because usually when you're given a function, it would be harder to do any analysis if it is in the form of a power series, right? Because power series means sometimes it is not divergent. You have to check for what x does it converge. And this topic was the main topic in the last two videos. And but nevertheless, representing a function in terms of a power series is still quite useful in some cases when you do some numerical analysis. And anyway, we try to look at a specific type of problems in this video. And please recall something. If you look at this ratio, I hope you remember something previously. We actually talked about it in the topic of the geometric series because this one is like the geometric sum, right? But this sum only applies to the convergent geometric series. If you recall that, it's very good. And based on our notations, the two parameters actually govern the whole geometric series, where A is actually the first term and the R is actually the fixed ratio of the geometric series. So it means in terms of algebra, we can present this geometric sum for the convergent geometric series by using the expansion like A, which is the first term, and the next term is what? The next term is the term A multiplied to the fixed ratio R. So it is A times R. And the next term is A times R squared, etc. And if you try to present it in terms of a summation, it's actually the summation of terms from n equals 0 to infinity for the term A times R to the power n. So why I'm looking at this kind of geometric series again, because it applies to certain f of x we would like to talk about. But before that, please read this formula very carefully. The fact is that the left-hand side may not be the same as right-hand side if the geometric series is not convergent, right? So we have to be very careful about this fact. We have to emphasize that this formula is actually correct when x is when the r, I'm sorry, is actually inside the range -1 to 1. Or the other way to say is the absolute value of r is actually less than 1. Then we understand that the formula is correct. And let's try to use this fact to apply to certain f of x, and we can get the power series quite quickly in that case. So please look at the current function f of x equals 1 over 1 minus x, right? And it is actually the same as the left-hand side of this equation. And it's kind of like a is actually 1 now. Please look at what we have here. And the x is actually r, right? So you can think of it, we actually have a geometric series now where the first term is 1, and starting from next term, you just have to multiply x to the first term to get to the second term, which is 1 times x, and the next term is 1 times x squared, etc. Because every time you're multiplying by x, right? And that's the geometric series we look at. It is the same as this geometric sum. And if you use the summation notation, it's the same as the summation from n equals 0 to infinity for the term 1 times x to the power n. Of course, this one is essentially x to the power n, right? And please be careful about these power series representations for our function 1 over 1 minus x, because based on what we talk about, it only applies to the case where the right-hand side is actually convergent. So basically, it is correct as a formula left-hand side equals right-hand side if the absolute value of the ratio is less than 1. And now our ratio term is basically x, right? So it means that in this short range where x is between -1 to 1, we understand that this formula is actually correct. And let's look at more examples from here. So please look at the current function, and we still want to present it in terms of a power series. And my note is that we can try to borrow what we learned about this geometric sum for the convergent geometric series. And I think we have to make it look like 1 minus something in the denominator. And what we can do is we can look like 1 minus 3x, right? And now you see they are exactly the same. Basically, a is 2 now, which is the first term, and the ratio term is -3x. So the right-hand side essentially means the convergent geometric series we look at. The first term is 2, right? The second term is a times r, which is 2 times minus 3x, and the next term is 2 times minus 3x squared, etc. So as a summation, it's a summation from n equals 0 to infinity for the term 2 times open bracket minus 3x close bracket to the power n. And that's basically the end of this convergent geometric series. But you have to tell me for what value of x does this formula work out. It is actually correct based on the geometric series test. We want the ratio be less than 1. So the ratio now is actually minus 3x, and because there's a negative sign inside the absolute value sign, so we can take out the negative sign. Basically, it's the same as the absolute value of 3x is less than 1. And I think we can resolve it. We can make it look absolute value of x is less than 1 over 3. Basically, it means all the x is between minus 1 over 3 and 1 over 3. And it's, to be honest, it's actually quite a short range of x such that our current formula is correct. Yeah, so for a very short range of x. And let's look at one more problem. So please look at the current function. I still want you to present it as a power series, which is a over 1 minus r, right? So I want to make it 1. And can you see how to do it by some algebra? So for example, you take 2 as a common factor out of the two terms. Of course, now the first term becomes 1, right? But the second term, we actually don't have the factor 2 here. So this one is kind of like a unnatural factorization, but that's the only way to go for such a problem if we try to use the geometric sum as a hint to write it as power series. Anyway, the second term inside the bracket, we can make it look like 3x over 2. And in that case, I think I can make the whole fraction at the top because it's just the constant term attached to the rational function here. So basically, we are having this term, and they are now basically identical if I let a be 4 over 2, which is 2, which is the first term here. The r is actually 3x over 2, which is the ratio term basically. So I can directly use the summation notation for the answer. So this one inside the summation should be a times r to the power n. So a is basically 2. And the r is basically 3x over 2, the whole thing to the power n. And basically, that's the end to this problem. And usually we have to try to be careful because such a formula is not correct for all x, because we are subject to the condition that we are looking at the convergent geometric series from the beginning. So it's only correct for the ratio term here to be less than 1 after taking the absolute value, right? And we can unravel this kind of problem to find all the x which satisfy that, because we can make it look like absolute value of x is actually less than 2 over 3. And it basically means this formula is correct inside the range minus 2 over 3 to 2 over 3. And that's the end to this problem.